Hi, welcome to another session of Finance Concepts with your Finance-ista, Cynthia Bush. Today I'm going to discuss zero coupon bonds. So zero coupon bonds can be issued by governments as well as corporations. There are no coupon payments with zero coupon bonds. And at the bond's maturity, the corporation still pays the $1,000 per bond face value, also known as the par value. But there are no coupons, hence its name, zero coupon bonds. Let's take a look at an example. Suppose we are standing here in October of 2021. Halloween Company wants to issue zero coupon bonds that are due in October 2026. Based on Halloween's risk profile, you determine these bonds should provide a return of 8.5% compounded annually. What should be the price of these bonds? So first, let's talk about that risk profile comment first. So individuals are assessed in terms of their credit worthiness. We call it our FICO score. And so most adults in the United States have a FICO score that indicates their ability and willingness to repay money that they borrow on time and in full. Companies are also rated along those same metrics. We call it a credit rating. And the credit rating indicates how risky it is to lend money to the company and whether you are likely to receive it or not. So based on Halloween's risk profile, you, the bond investor, have determined that in order for you to receive an adequate return, you need to get 8.5% compounded annually. The question asks, what should be the price of these bonds? That is another way of asking, what is the present value of these bonds? So let's take a look at it by using the equation. We are going to find the present value of a future lump sum. The future lump sum is the $1,000 face value that the borrower, Halloween Company, will be paying to you, the lender, upon maturity in October 2026. So that's the future value. In the equation, your N is the number of periods between now and maturity. So if we're standing here in October 2021 and the bonds mature in October 2026, there is 5 years to go before maturity, so your N is 5. Your I is your desired return. So the I, or the INT, stands for interest rate. That is the 8.5%. So notice in the equation, I've just filled in what I know, and I solve for present value. So I take 1.085, raise that to the 5. I get 1.5037, divide that into 1,000. So these bonds should be worth today $665.05. That is the present value of receiving $1,000 5 years from now, assuming an 8.5% return. We can solve this exact same question about what should be the price of these bonds with the financial calculator. Again, we plug in what we know. Your N is 5. Your I is the return you want of 8.5%. Your payment is 0. Your future value is the $1,000 face value that Halloween Company will pay to you as the bond investor upon maturity of these bonds in October 2026. You plug that in and you solve for present value. Notice you will get the same answer as if you do the equation. If you look at it on a number line, I've drawn a number line here with 5 years. The zeros at the bottom of the number line represent the coupon payments that Halloween Company will be paying to the investor every year for 5 years. For normal corporate bonds, that would be the coupon percentage times the face value, right? That would be a dollar figure. In zero coupon bonds, notice the coupons are all zero, just like the name of this. But the face value of the bond is still $1,000, also known as the par value, and that's what Halloween Company is going to return to the investor at the end of maturity of these bonds, which is October 2026. So when you do either the equation or use your financial calculator, you determine that if you want a return of 8.5%, that these bonds should be priced at $665.05. In other words, if you lend Halloween Company $665.05, and they promise to pay you $1,000 in 5 years upon the bond's maturity, and they do so, that is the equivalent of you receiving a return of 8.5%. So the cash flows look like this. Now I'm showing them from the perspective of Halloween Company. So Halloween Company, if they do issue these bonds, these zero coupon bonds, would receive $665.05 today. That's the present value. They would make no coupon payments, right? Zero coupons. And then upon maturity of the bond in October 2026, they will pay $1,000 to the lender. That means that Halloween Company is paying an implied interest rate of 8.5% to borrow this money under these terms. Okay, let's look at a different example. This is for Goblins Incorporated. They are issuing zero coupon bonds due 2033, October of 2033, that are currently trading at $820. So we're pretending we're standing in October of 2021. What is the yield to maturity of these bonds? That's another way of asking, what is the return that these bonds are offering if I'm the investor? So if I'm the investor and I provide $820 to Goblins Incorporated today in October 2021, what is the return that I would get from this investment? Let's look at how we find this. I'm going to now use the financial calculator keys, and we're going to plug in what we know. So our N is the time between now and maturity. So if this is October 2021, maturity is October 2031, our N is 10, representing the 10 years to maturity. There are no coupon payments in zero coupon bonds. So my payment is zero. So that would be very different than corporate bonds, which have a coupon payment. But in zero coupon bonds, your coupon is zero. The present value is where the bonds are trading today. So that's the $820. So if I want, I can either buy the bonds at $820 as an investor. 10 years from now, at bond maturity in October 2031, the company will pay $1,000. That's the face value / par value of the bond. So that's the future value. And notice in my calculator, I need to make that negative in order for this to all work. And then I solve for I, which gives me 2%. So another way of saying this is, if I lend Goblins Incorporated $820 today, and they give me $1,000 10 years from today in October 2031, that is the equivalent of me receiving a 2% return on this investment. If I look at it from Goblins Incorporated perspective, they borrow $820 today. They pay no coupon payments, but at the end of maturity of the bond in October 2031, they pay $1,000 to the lenders under this bond, also called the investors. That means Goblins Incorporated is paying the equivalent of a 2% interest rate for this borrowing. And let's look at the second question. If you have a desired return of 9.3% compounded annually, what price are you willing to pay for these bonds? Okay, so when you read this, assume everything else is the same except your return is different. The bonds are still maturing in October of 2031, which is 10 years from now, if we're standing in October of 2021. These are zero coupon bonds, so there are no payments. The future value is still the $1,000 that Goblins Incorporated will pay investors upon the bond's maturity 10 years from now. So this is what all of that looks like. Notice I made future value negative. I'm looking at it from Goblins Incorporated perspective. And now I'm going to solve for present value, which is $410.96. So what this says is, if I assess the credit quality of Goblins Incorporated, and I decide from a risk versus return perspective that I would like to have a return of 9.3% from this investment, then I should be willing to lend Goblins Incorporated no more than $410.96. If I lend them $410.96 today, they make no coupon payments to me, zero coupons. But at the end of 10 years, when the bond matures in October 2031, they pay me $1,000. That's the face value. That would give me a return of 9.3%. Now, the last question said, if your desired return is 9.3%, should you buy these bonds? So if the bonds are currently trading at $820 and you want a return of 9.3%, you should not buy these bonds. Because if you buy them at 820, look at the left, that would give you a return of 2%, and you want a return of 9.3%. So in your view, these bonds are overvalued at where they're trading. You don't think they're worth more than a penny of $410.96. All right, that's all for now. Until next time, this is your Finance-ista, Cynthia Bush, signing off.